Just kidding. Come on. What is he doing?
Somebody in the team.
Is your water bottle missing?
Wait, is it the big red one or the big red? Tiny red. How would I lose the big red one? Oh, I'm sorry.
I guess I should title this, huh? Completing the square. I like acronyms. They're easier to write. All right, nothing to it but to do it. We might as well just jump right in. Sure. We'll even wait on you, Kason. Okay, Mark, set, go. Do it.
All right, so it's like the when you take the square root of them and then you double it.
Oh,
that one.
Kason, you're exactly right. It is.
You get rid of the 4 somehow.
What is this called?
Perfect trinomial or something like that.
A perfect square trinomial. You did do this? Okay, so if you factor now remember, the whole goal of Unit 1 is what? Solving quadratics. And it's different ways of doing the exact same thing, right? Most of the time, I'm going to make it equal 0 and try to factor and solve, right? Completing the square is a little bit different because a lot of you recognize right now, but wait, that's a perfect square trinomial, and you're exactly right. And that's what you were supposed to see there, is that that's a perfect square trinomial. So if I factored that, just that left side, ignoring that 4 right now, what would it look like? Henry's trying so hard to ignore you. He's like,
I was asking about the unpredictable factor.
How does it factor on the left side?
7.
Okay, it's got a 7, but factor it completely. But you're right, that's the 7.
X plus 7
Close.
X plus 7
Squared. So remember, perfect square trinomials, they square dance, right? Square root, multiply and double for the middle, and that tells me it's a perfect square trinomial. And then if it is, I do the square root of the first, the square root of the last, and the first sign. But it's twice.
X plus 7.
What?
X plus 7 is 2.
You're half right. Remember, just as a reminder here, this is the one that gives you the 1 plus and 1 minus. It's the difference of 2 squares. Everybody gets these two forms mixed up because you would think since this starts out small, it ends small, and since this starts out big, it ends big, but it's the opposite. So it gets kind of confusing. Okay, so why is this handy? Kason already told us half the answer because that means X plus 7 is 4. Or that's why it was half the answer, or -2. You're exactly right, Quinn. So it's got to have the plus or the minus, right? So I'm essentially, because X is only written one time now, I'm just going to get rid of the radical. And I'm going to say it equals plus or minus 2. Does that confuse you? So this is sad map, since if I just started with just this equation, and I asked you to solve it, I hope you would just see 1x like on your quiz, and you go, oh, I can sad map that one because x is only written one time. And whenever I sad map, I need to work exponents before inside parentheses. So I would choop, right? Not like that. Yes or no? Do y'all see what I'm saying? Okay. All right. So if x plus 7 is plus or minus 2, then that means x is -7 plus or minus 2. And I'm going to break this into the two answers that it is. Okay. -7 plus 2 is negative 5. And negative 7 minus 2, negative 9. Does that make sense? That is not completing the square. That is factor and solve. But here's the thing. Do you see, once I get it to this point, do you see how easy the solve is? So what we're going to do is we're going to force that to happen. That's where the hard part's going to come in. So let me see how well you understand a perfect square trinomial. See, this is where I start coming up with my own, and we hope that they're good. What would need to go in the blank to make... Holy cow, that was fast. That was awesome. Kason says 25. He just did it very fast, but he's exactly right. 10 divided by 2, and then squared, right? What about... What's wrong? What did I do? What does that mean?
It's when you like set the
It means you're fast.
That's not true. That's not true. Let them do this one then.
Wait, no.
9.
Yeah, you got
Wait,
I'm not good enough at math.
Oh, blasting. We all laugh.
Well, you're the one you're messing with.
Yeah, that's gonna be the 6th case. Come on, you take My bad.
Anybody got it? How? Everybody, see, look, Kason, they all got smoke coming out their ears. Give it to me as a fraction. Oh, good Lord. Give it to me as an improper fraction. 9/4. Perfect. 9/4. Tell us how you got that. What did you do?
Divided by 2 and then 1.5 squared.
That's exactly what you did. Okay, but remember, well, you might not remember this. This is 3/2 times 3/2, which is 9/4. I asked you to leave it as an improper fraction because I just forced it to be a perfect square trinomial, yes? How does it factor? Perfect square trinomials always follow the same pattern. How does it factor?
X minus 3 squared.
X minus 3/2 squared. It's always the square root of the first sign, and the square root of the last squared. Are y'all okay? Okay, how do we get the 2? Because if I'm going backwards on that square dance. Whenever I look at it, remember it's the square root, I multiply them together and then I double them to get in the middle. So if I have the middle but not the end, what I do, I'm going to call, remember A is in front, this is B and this is C. I'm going to say it's take B, divide it by 2, and square it. Every single time. Okay? There's your little formula for you if you don't remember, and I hope that that helps. I am actually going to call this a good C. Because a good C makes it square dance. It wants to be happy. It wants to dance. So I make it happy and make it dance. So I give it a good C. If it's got a bad C, I'm going to throw the bad C away and find a good C. Okay? And I'll show you what I'm talking about. Let's do one more where you have to kind of think about it. Should I give you a hard one?
No.
Find the good C and then factor it. The wheels are turning. And leave everything as fractions, no decimals. What'd you get? Say it. Don't be scared. Don't be scared. What's 1/4? You're very close.
Oh, is it
1/8.
still one?
1/4 was closer than 1/2 is, but keep going with it.
1/8.
The 1/3.
Yes, Gwen, tell them why it's 1/16. What were they not doing? They got 1/4.
Oh, they divided by
You didn't square it. That's right. It's 1/16. So if I take the b and I divide by 2, well, dividing by 2 is the same thing as multiplying by a half, which is 1/4, but then I have to square it. If you didn't square it, you didn't finish, right? Y'all with me? How does it factor? Oh, that was supposed to be a square, Joel. I'm sorry.
1/4. Yeah.
X plus 1/4 squared. Everybody okay? Oh, it's not easy. It's definitely not easy. Now, this was a hard one. This is a... Let's do one more.
Wait, that's how we know it's there's probably a different one.
If you work with fractions rather than decimals, your life is a lot easier on these. Look at you go. All right, look what we're going to do. We're going to take b, multiply it by a half. If it's a fraction, multiply by a half. If it's a whole number, divide by 2. And we're going to square it. That's going to give me my good c, right? So half of 2/3 is 1/3. And if I square 1/3, I get 1/9. That goes here. And here's a little tricky poo for you. Nothing. This number before you squared it, because you want the square root, right? You've already found it. Don't come back and go, what's the square root of 1/9? You already did it. So it's x minus the number before you squared it, squared. But you're going to have to find this number, and I'm fixing to show you why. All right, what do you think so far? Okay. Let's move into solving then. If I asked you to solve that, you absolutely can't. As long as you do it to both sides. As long as you do it to both sides. Okay, so I don't know if y'all heard what he said, but he kind of picked up on the pattern from what we've done before. He is trying to make this side be a perfect square trinomial. So what he did was he said, this c, that's not working, right? So you can do one of two things. You can find out how many you need to add to it to make it what it needs to be. I usually move it because I see it a little better like that. And I go, wait, I'm just going to throw it away, right? Well, how do I throw away something in an equation? You move it to the other side, right? So I'm going to say x squared minus 18x. I'm going to leave a little hole right here. And I'm going to say negative 56 here. But I'm also going to put that same hole on this side because it's an equation. And if I throw it in over here, I also have to throw it in over here. I've got to add it to both sides because it's got to stay balanced. But I can add whatever I want as long as I do it to both. So now the question is, this was my bad C, right? That one was bad. Bad C. So now I need a good C. 81. Everybody sees 81. That's a much easier number than what we had before, right? 81. But it's an equation, and I am solving now, so it's going to both sides. So if you don't, this is my good C. If you don't remember how to find it, it's that little formula of 18 over 2 squared. Does it matter what sign I put on the 18? Why? Whenever I'm finding my good C, do I need to make sure I put a negative here?
No, it multiplies by itself.
Because it's squaring, it's going to be positive anyway, so it doesn't matter. Okay? So this gives me 9 squared, which is 81. And that goes to both sides. Y'all okay? Y'all want me to do steps for these, or do you like just the example better? Okay. Let's see. I'm going to put this step 1, but understand that we haven't done this yet, okay? So we're fixing to do one like this. If there's a leading coefficient get rid of it. Everything. We'll do one of these in just a minute.
Well, what if the other side's 0?
It doesn't matter. If it's still, even if the other side is 0, if you had something like 2x squared plus 10x minus 8 equals, even if it's 0, I can still divide both sides by 2 and get x squared plus 5x minus 4 equals 0, as long as I do it to everybody. But it does, if there's a number over there, then it also has to be divided by that leading coefficient. Some people like to make the equation equal 0 at this point. Some people like to, like what Henry was saying, just add it, whatever it is. And I tend to make it equal 0, but the more you do of these, you'll find your little, I'm not one of those teachers that you have to do it exactly my way or it's wrong. What makes sense to you, as long as it's mathematically sound, is fine with me. So if you want to move this C over here, you know, if you want to make the whole equation equal 0, whatever you want to do, but some of your equations are going to come out where it might say x squared minus 18x plus 56 equals 2. Okay, you might say, I want to make the equation equal 0 first and see if it's a perfect square. Other people might say, I just want to move this and find a good C. I don't even want to check to see if it's a good C. I just want to find my good C. If it is, it'll work itself out in the end. Either, it doesn't matter. It doesn't matter. But what I'm going to do at this point, so I've gotten rid of any leading coefficients. I want to get my good C. If it's already good, you can go ahead and factor and solve the way it sits. It's like the ones I was giving you in the very beginning. They were already perfect square trinomials. We could just factor and solve the way it was. And y'all know how to do that. That's like that one that was x squared plus 14x plus 49 equals 0. I can go ahead and factor that and solve it the way it sits, right? Or equals, I don't think it was it. Whatever it equals, it doesn't matter. But I could go ahead and factor because this is good. It square dances. Good means it square dances, right? If not, if it's bad, then I want to find a good one and add it to both sides. And then I'm just going to factor and solve. Am I going too fast? Okay. I'm coming back over here to this problem. So I found a good C. I added it to both sides. I'm ready to factor and solve. So how do I factor the left? Which is 9. So x minus 9 squared equals, what's it equal? 25. Oh, that's nice. Why is that nice? Because now I solve, it's a perfect square. I don't know why that thing keeps doing that. It's a perfect square, so I'm just going to go ahead and square root, and I get x minus 9 equals what? Plus or minus 5. So here's where you can split it here. I know I did this a different, I'll show you a couple different ways. I hope I'm not confusing everybody. You can go ahead and split it here into the positive and negative. You can wait until you add 9 to split it into the 2. It doesn't matter. You're still going to come back to 14 and 4. Will they all be that nice and pretty? No.
Oh. So what if it's not a perfect square? Like on the right side?
Well, I'm glad you asked. I think I shall show you.
Simplify it.
You do. All those properties and rules, imaginary numbers, simplifying radicals, rationalizing, all that comes back into play. Let's see if this one will. 8, 15, 8, negative 15. That one's difficult. Let's do a hard one. You might have one more. You might have one over complete the square and quadratic formula. Sometimes I give it, sometimes I don't. It depends on how we play it. Yes. We'll have a study guide before we. It's usually 20 to 30. It takes the whole block, but you have the whole block. I can give it to, if you need it early, I can give it to you early, but I usually give it, if the test is Wednesday, I'll give it to you in class on Tuesday and we go over it. I mean, go over it's a loose term. Y'all work together and do it. If you have any questions, I answer. And I give you the solutions. Are y'all scared? Why? Oh, I'm just kidding. It's okay. We're getting it up. Well, that's just because we don't have a test yet. What'd you say? 20 to 30. And remember, you got extra credit for Unit 1. That's a whole 100-point major grade. I'll give it to you. I'm gonna give it to you. But you don't get a 0 or anything. You just don't get anything. It doesn't help you nor hurt you. I don't know, because that's like big.
I'm sorry, I found myself.
All right. Somebody tell me what to do. Anybody, everybody scream. Get rid of the 4. Get rid of the 4. No leading coefficients. Complete the square does not work with a leading coefficient, okay? I'm just going to divide everything by 4. In pre-cal, we do it a little bit harder way, but in here, we start out this way, where we just divide everything by that leading coefficient. So I got minus 2x equals negative 3 over 4. What should I do now? I got rid of my leading coefficient. Find a good C. There's not even a C there, so I need a C, right? I need something, but I need to remember that whatever something I put here, I've got to also put here, right? All right. Half of 2 is? Squared is? 1. That's an easy good C, yes? All right. Oh, man, I picked another perfect square. Dang it. Okay, that's all right. We'll do one that's not in just a second. All right, so I've got x minus 1 squared equals, what's negative 3/4 plus 1? 1/4. That's not what you got, Henry.
Wouldn't it be 4/4?
Well, this is 4/4. So now it's, yeah. Whenever you add fractions, they have to have the same denominator. So it becomes 4 over 4.
No, it's not.
Negative 3 plus 4. Now remember, you do have your calculator if you can't remember how to work fractions. We'll keep pushing it. Hopefully by the time we get to calculus, y'all will feel good about fractions again. Yeah, you kind of have to. Half of it's non-calculator. But if you put on your calculator, remember fractions go in parentheses, and then you can always hit math, enter, enter to get it back into a fraction. Hopefully, though, it won't take till calculus until hopefully by the end of this course, you feel better about fractions. Fractions are easier to work with once you get used to them than decimals are, I promise. All right, how to solve it now? Square root. X minus 1 is, yay, plus or minus 1/2. I'll do this one this way so you see that either way is fine. X is 1 plus or minus 1/2, which means X could be 1 plus 1/2 is 3 over 2. And X minus 1/2 is 1/2. There are my two solutions, which means that my quadratic is crossing the x-axis at 1.5 and 1/2. Yes, Casey.
So, like, realistically, what's the point of doing all this if you just, like, put it in the graph calculator?
Well, what if they were imaginary?
Then would they be plotted?
Or what? No.
So then why do they exist?
In the imaginary world. Because the state of South Carolina said it's important. They said, teach these kids how to do this. We do this method in calculus a lot to manipulate polynomials to get them to certain forms so that we can do certain things with them. That only works whenever we get them like this. Here? It depends because I also have you for pre-cal. I kind of pick up where I leave off in here. So we get through as much as we can.
So say I went to my year, can I take pre-cal and then
Calculus is year long. Calculus is year long. It's fun. It's nice to be year long in math because we can really take it slow. And whenever there's things like that you struggle on, we can stop and slow down, take some more time for it. And then the last year it was 9 weeks of school. It's just straight review. All we do is review for the AP exam. We take practice exams and we practice problems like the exam. Yeah, just practice. Okay. If y'all can do this one, you can complete the square on. If the sun comes up tomorrow. I'm sorry, don't look. I'm just going to do this first part. That's not right. Yeah, that's not right. 36 is not. And have done it wrong. Notice that your x and your constant are on the wrong sides. These need to swap. Right? You could, but it's not a perfect square, so you might as well just throw it over there. Is the what? Always positive. It's always positive. What's 16? What'd you forget to do? Tell me how you find a good C. What do you do? And then
No, in the square.
square it. So what'd you forget to do? So it's 4. Miss McGee, what?
Oh, nothing.
Are you showing your toes?
I was saying I want you to normalize the knowledge.
You know, Katie, I don't even know what to say a lot of times to some of the things you say. I don't have a response. And that's unusual to render me speechless. It's not nothing to be sorry about. You're just original.
I agree with her.
No shoes is better.
I know. I flipped my flip flops. Like, I went to Walmart and I'm like, can you go in? I'm like, no, my mom. Like, I was driving. I drive my doctors all the time. I drive my doctors all the time.
I think that's illegal.
I went into Walmart. I didn't have therapy, but I went to Walmart.
Listen, I was on a job with snowshoes and flip flops.
Yeah, flip flops will get stuck. And they'll like piece of chocolate.
Oh my. Everybody get that? Is that your good C? Oh! I did that on purpose. No, for real. I needed to make sure y'all knew. All right. Factor the left. What do I get? X minus squared. What does it equal? Negative 15. Uh-oh. Danger, Will Robinson. What's wrong? What's fixing to happen? An I, a negative square root. That's exactly right. When I take this square root here, I end up with a negative under my radical. Before, I would say, I can't do that. But now that we're so smart, we say, oh, that just means put an I, imaginary. So I've got x minus 2 equals plus or minus I root 15. Add the 2 to both sides. Can you add 2 to I times the square root of 15? No. If you can't do it, write it and leave it. The only ones you're going to simplify are whenever they're like terms kind of thing, whenever you can. For this, leave it. Now, several things that I see mistakes all the time. Do not do this. Don't just throw a plus or minus in front of the radical. It's got to go in front of the other. Don't do this. None of those are the same, okay? When you move that 2 over, it's added to what's already there, and what's already there is plus or minus I root. Okay, so don't do either of those. What do you think? Good? Everybody okay? Just give you